Okay, for example number 6, we're going to go ahead and differentiate two different functions. The first one is this guy right here. So what we want is ddx of the natural log of 10x squared plus 1. Well, we don't have a direct formula for that, so we're going to have to make a substitution here. So let's let u be equal to 10x squared plus 1. So then what we're looking for is ddx of the natural log of u. But we can't do that because u is a function of x, so we've got to go ahead and use our chain rule. So this will be du dx times d du of the natural log of u. So d du of the natural log of u, we know that guy is 1 over u. So we'll get to that in just a second. But let's do du dx. Well, du dx is the derivative of this guy up top here. So the derivative of this guy is 20x. So this will be 20x times, and we just said that this was 1 over u. And so that will be equal to 20x over 10x squared plus 1. For b, we have the sine of the natural log of x to the third, like that. And then we're multiplying that by the exponential function, where the base is e, raised to the x raised to the fourth, like that. So we've got a function, two functions embedded inside another function, multiplied by a function which is also another embedded function here. So we've got composition floating all around all over the place, and we've got products. So let's go ahead and work through this. Well, this right here, okay, let's call this guy u. So let's let u be equal to the natural log. Actually, even before I do that, it might not be the end of the world, because the natural log of x to the third is just, we can rewrite this as the sine of 3 natural logs of x. Okay, like that. And so now we could let u be equal to the natural log of x, like that. And then we could let v be equal to 3 times u. And then I'm also going to let's say, I don't know, r be equal to x to the fourth, this guy up here. So what do we have to do? Well, the long part here is we've got to take the derivative with respect to x of this first function right here, which is the sine of 3 times the natural log of x, and multiply it by the second function, and then we're going to add to it the derivative of the second function times the first function, like that. So let's go ahead and work through it. This is going to be the more difficult guy to play around with. And so what I'm going to do is I'm going to replace this with sine. Now 3 times u is 3 times the natural log of x, so that's v. So sine v. Okay, and so I'm gonna figure this guy out right here first. So this is the guy I'm gonna calculate. Okay, so let's just go ahead and compute that guy. Well, I need this with respect to v. So this is going to be dv dx times d dv of the sine of v. Well, d dv of sine v, that's the derivative with respect to v of the sine function, that's cosine v. Now dv dx, well, what is that? Well, dv dx should be equal to dv du times du dx. So we want dv dx, so we have to take dv du, which is 3, and multiply it by du dx, which is 1 over x. So this gives me 3 over x. So doing my replacing here, I get 3 times the cosine of v, which is 3u, like that, over x, like that. Okay. So we've got the cosine of the natural log of 3 times the natural log of x times 3. Now I've got to multiply that. This guy's got to get multiplied by e x to the 4th. Just like that. Okay. It's not the only way of doing it, but this is about as good as it gets. So this guy right here, that's this whole guy right here. Now let's differentiate this guy over here. Well, that one's not too bad. Let's let m be equal to x to the 4th. Then we've got d dx of e to the m, which is dm dx times d dm of e to the m. And we know that the derivative of e to the m with respect to m is e to the m. But the derivative of m with respect to x is 4x to the 3rd. So this will give me 4x to the 3rd e to the x to the 4th, like that. So this is this piece right here. So what do we have all together? Well, we have this first piece, which is this. So we have 3 times the cosine of, now I'm going to move this guy back into here, just so it matches probably what your book's got, times e x to the 4th over x plus derivative of this guy we've got as 4x to the 3rd e x to the 4th times sine of the natural log of x to the 3rd, like that. So this is really, it's an ugly mess here, okay? So what I could do is the only thing in common that I can pull out is ex to the 4th. So ex to the 4th gets pulled out. What's left is 3 cosine natural log of x to the 3rd over x plus 4x to the 3rd times the sine of the natural log of x to the 3rd, like that. And that's your derivative.